In the next part of the class, we're going to be using statistics in order to estimate things. Now, what are we going to estimate? We're going to estimate parameters. And let's recall what a parameter is. That's a numerical summary of a population. So let's say, for example, I want to find what the average adult male height is for the entire population, for every single adult male. Or what if I want to find the exact percentage of people in the country that are going to vote for some new law? Or what if I want to find the exact standard deviation, the variation in the weight of adult males, whatever it may be? Any one of those things, when you want to try to find out information about the whole population, you are faced with a very, very difficult proposition. Because in order to get data from the whole population, you need a census, and census are really, really huge time and money sinks that it's just awful. It's really not reasonable for someone to have to do. I mean, we have the government doing it every 10 years, and they spend hundreds of $1,000,000 trying to do it, and even then, it's not perfect. And it turns out that even though we can't do a census realistically, we can actually take a sample and still get a pretty good approximation for what the population parameter actually may be. And there are two ways that we're going to go about this. One is pretty straightforward and easy, and the other one's going to be something you probably never thought of before. So the first thing is a point estimate. So a point estimate is a single number that is your best guess for the true population value. So if you're trying to find the true population average height for adult males, you're going to come up with a single number that is your best guess. That is called a point estimate. Now, that's good in that all you have to do is come up with a single number and that's your best guess, and you can just tell someone that's your single number. So it's easy to find. However, there's a problem, is that you're basically never going to be right. It's incredibly unlikely that you are going to happen to pick just the right number that is the true population value, the true parameter. And so point estimates are easy to find, but they're in one way always wrong, because you're never going to get the exact right number, but the idea is hopefully at least they're close to the true answer. The other way to estimate parameters is kind of a big thing in this class and something you've likely never seen outside of this class, and that's called a confidence interval. So a confidence interval is a range of values that you believe the true value of the parameter is in. So instead of saying, I believe the true average height of the adult male is 5'10", instead of giving one number, I'm going to say that I believe the average adult male height is somewhere between 5'8" and 6 feet. Now I'm giving a range of values there, and that means there's actually a decent chance that I will actually be correct, that the true value is somewhere between 5'8" and 6 feet. Now, of course, I could be guaranteed to be right if I said I believe that the true average height for adult men is somewhere between 0 feet and 30 feet. I would be completely correct that it's somewhere between 0 feet and 30 feet, because all men are somewhere between 0 feet and 30 feet tall. And so therefore the average has to be in that range as well. So the thing is when you have a confidence interval, if you just make it really wide, you're guaranteed to be right. But the problem with that is it's not very useful. If you tell someone that you think it's between 0 feet and 30 feet, you're not really giving any useful information at all. Whereas if you say you believe it's between 5'8" and 6 feet, that actually is going to be useful information. So you want it to be fairly narrow to give information to actually be useful. But the more narrow it is, the less likely you're going to be correct. And so there's kind of these competing factors of, if it's more narrow, it's more useful, but if it's more wide, it's more likely to be correct. And so what we're going to then do is we're going to have something called the confidence level. So the confidence level will tell us how often the confidence interval will be correct for random samples. So what I mean by that is, let's suppose I want a 95% confidence level. What that means is, out of every 100 random samples, about 95 will include the correct parameter. So if you were to repeat the process that we're going to learn about how to find a confidence interval, you take 100 different samples, you create 100 different confidence intervals, each at the 95% confidence level. That means out of those 100 confidence intervals, about 95 of them are actually going to have the right answer somewhere in that range. So maybe your first confidence interval is somewhere between 5'8" and 6 feet. Maybe your second confidence interval is 5'6" to 5'10". Maybe your third confidence interval is 5'10" to 6'2". So each confidence interval is a different range. But we're saying is that if you have a 95% confidence level, that means about 95% of the intervals you create are going to include the actual correct value. Okay, so I want to point out one thing here that is a very common misconception, is that when they say we have a 95% confidence level, that means that the one confidence interval I have is a 95% chance that it's right. That's not quite an accurate thing to say, because when you know that there are 100 different confidence intervals and approximately 95 of them are right, each one of them though is either right or it's wrong, guaranteed. So that it's either a 100% chance for one of them that it is correct, or a 0% chance that it's correct if it's wrong in that case. And since the specific interval we have, once we have it, it's already been determined. There's no longer a probability associated with it. It's either right or it's wrong. It's a little bit weird thing, a little bit overestimating. I just want you to understand that the 95% confidence level is not quite the same thing as saying that the one answer I'm giving you is 95% correct. It's a really unfortunate terminology that they kind of put it that way, but that's how it may be. Now, the last thing to talk about is what is the margin of error. So the idea is you're going to have your point estimate, and then you are going to add, subtract some number, which is going to be called the margin of error. And this together is going to be your confidence interval. So let's say your point estimate for whatever problem you're talking about may be is 7. And the margin of error that you calculate is 3. So what that means is you put them together to make your confidence interval. You would say, okay, what is 7 plus 3? That's going to be 10. That's your big number on your interval. What happens if you do 7 minus 3? That's going to be 4. And so that would mean that your confidence interval, what you believe the parameter is somewhere between 4 and 10. So every time we're building a confidence interval, we're going to need two things. We're going to need our point estimate, which again, we'll learn how to find that for different scenarios. Then we're going to need our margin of error. Again, we're going to learn how to find that for different scenarios. And then we're just going to add and subtract those two numbers. And what answers we get from that are going to be the range for our confidence interval. So we say we are X% confident that the true value is somewhere between 4 and 10 in this case.